All right, so we're going to talk today about molality, which is our other version of concentration. What was the name of our first concentration that we looked at? Molarity, good. And its unit was what letter? Capital N, right? A big M. Okay, so molarity is big M. Molality is little m. Molality is going to be measured in moles of our solute, which was the same as molarity, but now it's going to be over kilograms of our solvent only. Okay, so the bottom unit for molarity was liters of our entire solution. This is now just kilograms of our solvent, just the solvent. So just the amount of water or just the amount of liquid that's going to be the solvent in this particular solution. We'll convert that to kilograms. So to review of kilograms here, 1 kilogram is going to equal 1,000 of the base unit, which is a gram. Remember, kilo means 1,000, so a kilo is always 1,000 of whatever base unit we're talking about. So to convert from grams to kilograms, we would use the same process as converting from milliliters to liters. Okay, when we go from grams to kilograms, we will divide by 1,000. Okay, 1 kilogram equals 1,000 grams. We talked about this just a little bit last class, is that the density of water is 1 gram per milliliter. This is basically telling us that 10 milliliters of water is going to be equal to 10 grams of water. If we convert that to kilograms, that would give us 0.01 kilograms of water. All right, we're going to have to use our density equation pretty often in molality because we have to convert a certain number of milliliters or liters of a solution or a solvent into kilograms of that solvent so we can put it into our concentration equation. Do we remember the equation for density? Yeah, D equals m over v. All right, so you might want to write that equation down to go along with this chapter because we might be having to use that pretty often. And what are the units then for mass and for volume? This should be grams per milliliter. Okay, so units for density need to be in grams per milliliter. All right, and when we look at other liquids, they won't have a density of 1, they'll have some other density, so we might have to use our density equation to solve for the number of kilograms of that particular solvent. Let's just go ahead and try some molality problems then. Go ahead and take a few seconds to get this written down, and then we'll talk through the steps. If you don't have your calculator out, now would be a great time to get that out. In this problem, which of these will be our solute?
Sodium phosphate.
Yeah, good. Sodium phosphate will be our solute. And the chemical formula for sodium phosphate is Na3PO4. Very good, because sodium is a +1, phosphate's a -3. That's our chemical formula for sodium phosphate. First thing that we need to do is go ahead and convert our solute from grams to moles. So we'll start with the T-chart down here. 18 grams of Na3PO4. And the molar mass of sodium phosphate should go here, which is what? Do we agree with this molar mass? Yeah? Okay, good. So now we're going to take 18 divided by that, and we'll get our number of moles. And I got about 0.109. Yeah? Okay. So that's going to be our moles of solute. Remember, we're solving this time for molality, which is little m. Little m equals moles per kilogram, okay, or moles over kilograms of our solvent. So we have moles, and we are given 1,302 grams of water. How do we go about solving and converting this grams to kilograms? Yeah, we can move the decimal place 3 places, or we can divide by 1,000. So what we're going to end up with here is 1.302 kilograms of our solvent. All right, so we're going to solve M equals 0.109 moles divided by our kilogram amount, which is 1.302. And so what do we get for our final answer? 0.08. Okay, and our units for molality is just a little m. So 0.08 m. Make sure that we understand the difference between a little m unit and a big M unit, okay? Because that means it's a different concentration. It's a different type of way that we calculate that, so it gives us a little different concentration. So little m is molality, big M is molarity. Let's go ahead and try this problem. It's pretty much the same type of process here, so you should be able to do this one on your own. So let's go ahead and take a second, do it on your own, and then we'll see if we match answers. Okay, so the chemical formula for nitrate is NO3-. Does that negative charge, that extra little one tiny electron, have any effect on its molar mass? No. Okay, that addition of that one tiny electron has absolutely no difference on its molar mass. So even though it's a minus charge, we don't have any change in the molar mass here of nitrate. All right, let's go ahead and try another one here where water is now no longer our solvent. We have a different type of solvent in which we have a density equation we'll have to work with. Okay, so go ahead and get it written down, get it started on our conversion of grams of salt to moles, and then we'll work through these steps to get our final answer here. Okay, let's start first things first, and we'll convert our grams of salt here to moles of salt. So 41 grams of NaCl. The molar mass of salt is 58.5. So what do we get for the amount of moles? Point what? Point what? 0.70. Okay. So that was the easy part. Now we need to take our ethyl alcohol and convert this density into the amount of kilograms we are able to put into our molality equation. So if we know the density of this substance is 0.789 grams per milliliter, we want to get to basically an amount of milliliters here, okay? So we want to get to the amount of grams. So we have the amount of liters, basically, and we have the density, so we need to convert that into an amount of kilograms that we can put into our molality equation, okay? First thing that we need to do is convert this liters back to milliliters so we can use our density equation, because in our density value, we were given grams per milliliter, and this is in liters, and those two don't match up. We've got to put that in milliliters first, okay? So 2.7 liters is equal to how many milliliters? 2,700. If we move it 3 places to the right. Okay, so we're going to use our equation D equals m over v. We were given our density value and we were given our volume. Okay, and we're trying to find the mass here. We want to find out how many grams of this solvent we have. So the density is 0.789 grams per milliliter. And we're going to solve for our mass. And we know we have 2,700 or 2,700 milliliters. What math do we have to do to solve for our mass here? We're going to multiply these two together. So take 0.789 times 2,700, and that's going to give us how many grams of this solvent we have. That's how many grams I got. Do we agree with that? Okay. So now can we put this gram value directly into our molality equation? No. What do we need to do with that gram value? Convert back to kilograms. Okay, so then to convert back to kilograms after we're finished here, we're going to move the decimal place 3 places, and that leaves us with 2.1303 kilograms. Now we have moles. And we have kilograms, so we can plug in m molality equals moles per kilogram. And I got about 0.329. So 0.329 m would be our answer here for molality. That's its concentration. If it didn't ask us for the concentration in molality, we could have just plugged this in as our liters basically for our molarity equation. But it asked specifically for the concentration in molality, in which case we had to do some conversions to get it to kilograms. Okay? So we'll try one last one here using some density equations again. This is a 2.1 and it's a little m, so this is molality. That's its concentration in molality. We have lithium sulfate. We've got a volume here of hexane. We want to find out how many grams of lithium sulfate we need to get that certain concentration. So can anyone give me the first step we need to go through here? Yeah, the first thing that we need to do is convert our liters of hexane into kilograms, because we were given the overall concentration of the solution and we were given liters of hexane, but we need it to be in kilograms to fit into our molality equation. So we'll go down here. They gave us the density and they gave us the volume. So D equals m over v. We'll say our density is 0.660. We want to find the mass, and we know that this volume is in liters, but we need it in what to match up with our density unit? We need it in milliliters, okay? So we've got to be careful when we switch back and forth with these equations because some of them we want grams, some we want kilograms. You've got to pay attention here. On density, it's in grams per milliliter. So both of these units need to be grams and milliliters. Okay, so if we have 1.3 liters, that means we have 1,300 milliliters. And to solve for m, again, we're just going to multiply these two numbers together. 0.66 times 1,300. And I got 858 grams. Okay, so that's grams of our solvent, and we need it in what? We need it in kilograms, so we'll move that decimal place 3 to the left, and that leaves us with 0.858 kilograms. So now we have kilograms, and we have the molality. So we should be able to solve for moles, in which case will lead us closer to finding out how many grams of lithium sulfate we can have. Okay? So our molality is 2.1. That's going to be equal to moles over how many kilograms? 0.858. If we want to solve for moles right here, we need to do what to these numbers? Multiply them, okay, just like we did in the last time. So 0.858 times 2.1 gives us 1.8 moles. And how do we convert 1.8 moles of lithium sulfate? We want to divide by molar mass. Good. What's the chemical formula for lithium sulfate? Good. Li2SO4. Because sulfate is a -2. Lithium is a +1, so we cross down those charges when we go to form our molecule and we get Li2SO4. So can someone give me the molar mass of lithium sulfate?
172.8. No, 96.
Okay. 96 grams. Is that right? Okay, so no, not 96 grams. 110 grams. Do we have some better confirmation on that? Okay, good. So now we're going to take 1.8 times 110, and we get 198 grams of lithium sulfate. Li2SO4.